My name is Dinesh. I'm working as a regional practice lead at Terraform. I'm AWS ambassador, Pulumi, and part of the AWS Community Builders program. Today, we're going to talk about a really interesting topic. The topic is reverse engineering AWS using Pulumi. So before I start on this topic, I just quickly want to gauge the audience here. So how many of you know about AWS or elementary knowledge, or are you still learning AWS? Nice. Awesome. How many of you here know about CloudFormation? Good, good. What about Terraform? Nice, nice, nice. And what about Pulumi? Hey, awesome, man. And any Troposphere fan here? Do you know anything about Troposphere? Okay, cool, that's all right. So before I jump into the presentation, I'll quickly go into the AWS console, and I'll try to do some changes, which I promise is going to make sense at the end of the presentation. So what I'm going to do is, I'm going to add a tag. So I've added a tag env test. And now, after adding the tag, I'll come to the pipeline and I'll try to release it. Let's cross-check if it has been. Awesome, so cool. So let's get back to our presentation. Right, so as I was saying, that what I've done in the console, it will definitely make sense at the end of the presentation, right? So back to the topic, reverse engineering AWS using Pulumi. So this whole thing started last year at the end of the AWS Cloud Day, which was held in Auckland, I think was August last year. So at the end of the event, I was really motivated to build a solution that can help in DevOps engineering field. So I was like, I started brainstorming some of those ideas. So in order to brainstorming the ideas, I was like, let's evaluate my own skill sets first. So I was like, what am I good at? I was like, I'm good at bullshitting. No, just kidding. So I was like, I'm good at AWS architecture, designing, infrastructure as code, Terraform, Pulumi, and all of a sudden, I had that light bulb moment where I was like, what if there's a tool or a stack that can help you reverse engineer the already deployed, already created resource, and it can help you to create the infrastructure as code for it. And 1 year down the line, today, I would like to share the advancements or the progress I've made with that tool. So without wasting any time, let's get into it. So every time when I'm working on a solution designing, and this is pretty important for all the people here who are starting in AWS as well. So every time when you are working on a solution designing, always evaluate the solution against these three principles: the what, why, and how. So let's quickly evaluate the solution against these components first. Right, first of all, what is it? So it is a tool, stack, or a solution that can help you reverse engineer already created or already deployed resources in AWS, right? So normally what happens is you first create the infrastructure as code and then deploy the resources. But in this case, we are creating the infrastructure as code for the resources which are already deployed. So you must be wondering, why? The problem statement, why do we need it? Answer is, so imagine if you have an environment which is completely manually deployed, right? Even if you want to code control your environment, just because of the sheer size of the environment, you won't be able to code control it. You may want to do it, but there's no other way to do it. But if you're in a similar boat where, although you have deployed your environments manually, by manually I mean ClickOps, you can look at the stack. And then you can use the stack, and that will help you to reverse engineer and create the code for it. The second use case is drifted deployments. So you may have started with a code-controlled environment, but somewhere, somehow, someone did a manual change, which led to another change. and another, and another. And all of a sudden, it's a wild, wild west, because all of a sudden, you are so drifted from your code, a single code deployment can prove to be disastrous. God knows what effect it can have on already deployed resources. So in those resources, in those scenarios, you basically just want to start from scratch. You just want to start from clean slate, but without affecting the current resources, right? So if you're in a similar boat, please feel free to use the solution. The next use case is move away from CloudFormation. So I love CloudFormation. I have used CloudFormation a lot, but CloudFormation has its own limitations. If you're in a similar boat and you feel like CloudFormation is not basically serving all the purpose, and if you want to use something which is more code friendly or developer friendly, you can look at using the stack. And last but not the least, and dare I say, if you want to move away from Terraform, and with all the latest changes happening inside Terraform, you may want to try the open waters. You may want to try what else is there in the market. So if you're on a similar boat and you want to move away from Terraform, feel free to use this stack. Now the question is, how? How are we going to solve this? So we're going to solve this problem by implementing a fully automated code pipeline written in Pulumi. So the solution is a fully automated code pipeline, which A, creates a code commit repository for all the imported resources. B, creates a Pulumi code for all the targeted resources. And once the Pulumi code is created, it imports the stack into, import the resources into the stack. And D, after the resources are imported into the stack, it's going to push the code to the code commit repo. And at the end, wait for it, it's going to automatically create the architecture diagram for all the resources which are imported into your Pulumi stacks. So basically, it's a one-stop solution to reverse engineer your entire environment. And if you're in a similar boat where I was discussing about all the use cases, within a minute or probably 5 minutes, depending on how big is your environment, by the time code pipeline finishes, you have transformed your environment from being completely no code control or semi-code control to completely code control. Right, so next is the components I've used to build the solution. Needless to say, for infrastructure as code, I'm using Pulumi. And for AWS services, the idea was to build all-in-all AWS solution. So I'm using code pipeline, code build, and code commit. But due to the recent changes inside AWS, AWS has decided to depreciate code commit. Because of that, I'm going to be moving away from code commit and basically be adding GitHub support to it, which would actually be helpful in supporting all the other use cases as well. And for the Python package, I'm using diagrams library to dynamically create the architecture diagram. Next is the services supported by the solution. So as I'm the only one who's developing this solution, I started by including the most commonly used services. So for the time being, the solution supports VPC, EC2, RDS, IAM roles and policies, and S3. So in short, you can use this solution and reverse engineer any of these services. Doesn't matter how many RDS instances you have, how many EC2 instances, and how many VPC. At the end of the pipeline, you're going to get the code ready. Right. Next is code pipeline. Let's have a look at the different stages used inside the code pipeline. Right. Stage number one. So stage number one is a source stage. It looks at a code commit repo, which has the code for all the targeted and all the supported services. So what this code does is it executes the get API call to all the supported services and tries to gather the information required, which will be used further to import all the resources into the Pulumi stack. The next stage is it basically creates a S3 bucket, which is used to store code pipeline artifacts, and it creates a code commit repo, which would act as a final resting place for all of your resources imported into Pulumi stack. Next stage, which prepares the import file, a really important stage. So as I was explaining earlier, the code executes the get API call to generate these individual JSON file for individual services. So you can treat, like if you are familiar with Terraform, you would know what state file is. It is like state file, but actually not a state file. So it executes the get API calls and tries to gather the information for all the targeted resources and constructs the JSON file for individual services. And then the same JSON file is going to be used in the next stage. So this is where the magic happens. So at this stage, this uses the JSON file which got created in the last stage and uses the JSON file to import all the resources mentioned inside the JSON file into the Pulumi stack. And once it does that, it also pushes the code to the code commit repo. So by now, you have a freshly created code commit repo with the code for all of your reverse engineer resources. So this means that, for example, the first folder, which is imported resources EC2, right? This will have the code, for example, if you have like 10 EC2 instances, this folder is going to have the Pulumi code for all of your targeted EC2 instances. Same as with the RDS, S3, and VPC. The next and the final stage of the pipeline is the architecture diagram. This is the latest addition into the tool. So what it does is it dynamically creates the architecture diagram using the diagrams library. And it is basically it shows you the current landscape of your AWS environment in terms of the resources which got imported into Pulumi stack. And once the architecture diagram is created, the architecture diagram gets also pushed to the repo. So by now, which is the end of the pipeline, you have a full code commit repo with all the code for all of your imported or reverse engineered resources, plus an updated architecture diagram which shows the current state of your AWS environment. Right. Next is the demo. Let me just quickly play this while I'll try to explain. And my apologies, I know it's a bit blur, but that's the best we can do in terms of the clarity. So I'll explain what I'm doing here. So as part of this demo, I'm trying to add a route to a route table, which belongs to a DB subnet. And then DB subnet belongs to a VPC. And all these components were created and managed using CloudFormation. But because I have imported this VPC and reverse engineered and created the Pulumi code, and now I can control, modify, add, delete any of the component inside the VPC using the Pulumi code. So as part of this demo, as you can see, that I've uncommented a code which basically creates a default route pointing towards the NAT gateway and applied the changes. So soon you'll see the change gets applied. It takes around like 10, 15 seconds, so let's just wait. So by the way, are you guys getting it? Cool. Right, so started creating and boom. The route got added and we'll soon go to the console to verify it. And in the console, we'll go to the route table and go to the routes, and there you have it. The default route pointing towards the NAT gateway. So what this demo tells us? So this demo tells us that even though the resource was created using CloudFormation, it could have been Terraform, it could have been manual, it could have been Troposphere, it could have been anything. But now I can reverse engineer and created the entire Pulumi code for all the components included in the VPC, and now I can manage each and every component. Yeah? And it could have been an EC2 instance, it could have been RDS, it could have been S3, it could have been IAM roles and policies. Regardless of the resource, supported resources, I could control and manage each and every component. Next is a quick demo of the architecture diagram which gets created. So as you can see, it creates a really nice color-coded architecture diagram, which basically shows the different types of subnets and the EC2 instances and RDS instances inside the subnet with the security group nicely labeled, the NAT gateways, internet gateway, the S3 bucket, basically the whole ecosystem of your AWS which got imported into your stack. Pretty cool, right? So I was doing a test the other day, and I tried importing an EC2 instance into the Pulumi stack, and I ran the pipeline. And by the time pipeline finished, I already had my architecture diagram updated with the new EC2 instance imported into my system. So what this tells us? This tells that long gone those days where you create the architecture diagram and 6 months down the line, the architecture diagram is already drifted. And you have no idea how the architecture diagram looks like in terms of your stack, right? But this way, the architecture diagram is well living and breathing, and it gets changed every time when you make a change to your stack. Pretty cool, right? Right. So the next section I would like to add, I would like to talk about is some of the features which I want to add to the solution. So as I was explaining earlier, currently it supports VPC, RDS, EC2, S3, and IAM. But currently I'm working on to add the support for ECS and EKS as well. No brainer, because these are the most popular container platforms. The second feature I would like to add is the support for multi-account deployment. So currently you can reverse engineer the resources inside the single account. But the idea is the solution can fan across multiple accounts, and you can reverse engineer the resources from one pipeline into the multiple accounts. And at the end of it, you have basically reverse engineered probably the entire organization. Right. The third use case is I'm working on adding the support for transit gateway attachment, and central net. So just so that the solution can cover the advanced networking use cases, because like some of the customers or some of the environments have like central network hub account, which has got things like VPNs, transit gateway, cross-account networking. So currently I'm working on, and soon the support would be added for these elements as well. Right. The next one, dynamically redefine the code or dynamically modularize the code. So when I was working on the solution, I was like, man, I need to use AI, because why not, right? Like AI has been the flavor for AWS from the last couple of years, and I'm like, I want to use AI, but I'm not too sure where. So turns out, I am currently working on a solution which will basically, it will be an AI-driven solution that will help me redefine the code or refine the code and help me modularize the code. So what do I mean by that? Currently, the code which gets spit out at the end of the pipeline, it's a nice Python code, but it can be refined. What do I mean by that? So for example, let's say if you want to create subnet, right? So you have 6 subnets. So in order to create 6 subnets, you may have 6 blocks of code creating 6 subnets, right? But the code can be further refined. How? So instead of having 6 blocks which create 6 subnets, you can have one function or subnet which can be called X number of times. Yeah, and that way your code is much shorter, much more refined, and basically it's more modularized. Next is enhancing the architecture diagram. So again, same, integrating the diagram creation using the AI so that the architecture diagram can support enhanced feature, and it can support few of the things which are currently not supported as part of the diagrams library. Right, the last one, I mean, why not? I'm really excited for this feature. So by this time, I can refine the code using AI. I can refine the architecture diagram using AI. I mean, why not do the documentation as well? So the idea is, at the end of the pipeline, it also creates the architecture documentation. And once it creates the architecture documentation, the documentation gets pushed to your central place like SharePoint or Confluence, and happy days. Like at the end of the pipeline, you have the entire code, architecture diagram updated, and the documentation. Pretty cool, yeah? Right, so let's go back to, as promised, let's go back to the console. So the pipeline is finished. Okay, just have a look at this. And God help me, because like normally the demo basically, oh, am I not sharing it? Was I not sharing the entire lot? I was, right? Thank God. I was like, Did I just not? Okay, that's good to know. Cool. Yay. Again, sorry for the visuals can be better. So let's see if demo god basically allows, because like sometimes when you're doing the live demo, it depends upon the demo gods, that demo can fail because technology, right? So, God bless you. As you can see, how many EC2 instances we have here? 3? Yeah. And 1 in the subnet, yeah? So what I did initially, so if you remember, I added a tag to the EC2 instance and I ran the pipeline. So basically what I did was I imported that EC2 instance inside the pipeline, right? And what it means, by now, the architecture diagram should be updated and I should have a code ready for my 5th EC2 instance, right? So let's see, I'm gonna refresh it and hopefully, and don't blame me if it's not there, I'll just blame the technology. Boom. So there you go. 2 and 3. So what it means that the EC2 instance which I tagged and I ran the pipeline, now the EC2 instance, by the way, the EC2 instance was this one. So this one, one of this. So what it means that as soon as the EC2 instance was added to the pipeline, at the end of the pipeline, my architecture diagram got updated automatically. Yeah? And let me just quickly go and check out the code as well. So this was the EC2 instance, right? Test 5. And this is basically the code which got created, yeah, from line 2 to 5 onwards. So this code got created when the pipeline finished. So what this tells me, that now I can control that 5th EC2 instance as well using the Pulumi code. And the architecture diagram updated as well. So what this tells us, that now I don't have to worry about the architecture diagram. My architecture diagram would get updated every time when I'm doing any changes inside the stack, right? So pretty kinetic, I would say, that it gets updated every time you make a change to your stack. And that's it from my side, guys. Thank you so much for listening to me. And before I finish, I just quickly want to say one last thing, that you may have ideas in your mind. Doesn't matter. It could have been small ideas, big ideas. It really doesn't matter. The thing that matters is you need to start acting on your ideas, right? Do not worry about how the idea is going to look like in 1 year or 2 years, 5 years. Do not even worry, because if you're worrying about what's going to happen in 2 years, you may not be able to start, right? So all you have to focus on, the very next step, and do the best in your ability to finish that step. Once you do that, take on the next step, and next step, and next step. Because you have to work on your dreams. Because if you don't, maybe nobody else will. That's my time, guys. Thank you so much for listening to me. Really appreciate your time. Thank you. Questions? Yes. Questions? And we can turn on the lights now. Better, yeah. Questions?
The question about the code commit. When you do change on the AWS, you refer to the code repository, right?
Yes.
And is that when you do some change in the code repository, if you also refer to the actual AWS environment?
So the code basically gets committed as part of the code build. So every time when I'm basically doing the changes, the code basically gets updated. So first what happens is the code gets executed. After it gets executed, it gets pushed to the code commit repo.
I
Yeah.
to modify
Yes.
the resource, do you need to do something to make that change apply to the AWS, or it will just do it automatically?
So it happens, everything happens automatically. So it basically first deploy the changes into the AWS, and then the changes of in terms of the code gets pushed to the code commit repo.
I mean now your solution is the reverse engineering is to
Yes.
convert the actual AWS resource
Yes.
to the code.
Exactly.
And I wonder if we, after convert to the code and I make some change on that code, does it automatically deploy?
No, good question, really good question. So what happens is, really good question, by the way. So when you make, so for example, you have your code ready, yeah? So once you have your code ready, then you need to have another pipeline, because remember, this pipeline only reverse engineers the resources. But if you want to use the same pipeline for your CI/CD purposes, then you basically need to have another pipeline which basically gets updated and triggers the changes which you're doing in your stack. So the idea is that this pipeline would help you in creating all the code. But then it's up to you, and that's why I said that you will have a fresh code commit repo which is ready to be used. So then you can basically integrate and create a new pipeline and then look at that repo and then do your business. Jeez, good question.
Like as you said, like we can reverse engineer your AWS policy into the code. If I want to create a new EC2 instance,
yes,
I can just copy the last test file.
Absolutely.
And just copy and paste. And
but this is this.
Can I run and it will create an EC2 instance or not?
Okay, so it will, but if you're just copying that code and then you're trying to run it, it may error out if you're trying to run this inside the same account, because it may say like, hey.
I know,
Yeah, but absolutely.
I can change, like
the name, the tags, exactly.
Name, tags, and the type.
Absolutely.
Change and I can run, right?
Yeah, absolutely. So that's basically the use case here, that the code is ready for you. Basically, just cut and paste, and then you can use it. Yeah, but if I was you, once I have the code ready, I would rather basically just like start building on it, right? So if I have the, like for example, let's say I reverse engineered 10 EC2 instances, right? And I have the code for 10 EC2 instances. So for the 11th EC2 instance, I can copy the code, like no problem, but I'll have to make certain changes so that it doesn't reflect to the one which I copied from. Yeah.
Can we get this part of a resource? For example, you say I want to get, like, I already do a BCP and I only want to see, instead of doing it in Pulumi, I want to see use the resource of the BCP on Pulumi, for example, Pulumi code.
Yeah.
Can I just get like this part with like what you have is like running and everything, not like easy to BCP and everything.
Okay, so you're saying like if you want to just reverse engineer just the VPC, not everything else. Good question. So I'll need to add this feature to the pipeline so that like you can basically pick and choose if you only want to, let's say, reverse engineer just the VPC or all of them. So good question. So I'll look into it and basically add the support for that.
Like Puppet have like this Puppet resource, and you put a Puppet resource user.
Yeah.
That one, and then you like how it looks, and then you just.
Yeah, exactly. Yeah. You can. But the pipeline basically does a lot of other things as well, basically creating the architecture diagram, creating the repo as well, because sometimes what happens is that you may have a repo or you don't have a repo, right? But sometimes if you're just starting from scratch, the pipeline would just help you by creating the code, the repo, and the architecture diagram in less than 5 minutes. So, yeah.
First question. How can I use your solution? Is it like open source or?
So really good question. So I haven't made it public yet, and then there's a reason, because like I need to make certain changes, add certain features, and have to move away from code commit to GitHub because of the dependency. So once I've done that, and please connect me on LinkedIn. I would love to help you guys as well. Like if you have any questions in terms of AWS, from your career point of view, or like anything, because like code build does a lot of things, and it needs to have the access to the IAM roles policy so that it can gather that information. Yeah. That's it.
Okay. Last two questions.
Okay.
It may not be a question, but I really want to consult your opinion of using it. Because in my opinion, there's, apart from Terraform, there's no difference compared to Terraform.
Okay. Good question. So the key difference between Terraform and Pulumi, and maybe I'm a bit biased towards Pulumi, yeah? But to be honest, like I have used CDK, I have used Terraform, I have used Pulumi, I have basically used everything. According to me, Pulumi gives you a lot more options in comparison to Terraform. And let me explain how. So with Pulumi, because you can use Python or your native programming language, you can create the loop which can basically help in optimizing your code. Like for example, I've also written a blog on this. So if you used Terraform in a multi-account, multi-environment, I don't have to explain to you how hard or how cumbersome it is to work with Pulumi and work with Terraform. And most of the time you will end up using something like TerraGrunt on top of Terraform to basically work with different accounts and stuff. But with Pulumi, I've written a blog, was hardly like 19 lines. And what it did was, it created like more than 100 something resources across the entire organization in 6 to 7 different regions. I can't remember the specifics, in less than 2 minutes and like 11 seconds or something. And I didn't have to do anything, just 11 lines of code. So I love Terraform as well, by the way. But if my money is on the line, if I'm building something, I'm going to use Pulumi. But it's true that Pulumi is not gaining that much momentum, and there's a reason, because Terraform is widely used, and it's hard to find the Pulumi resources. But as long as like young guys like you who start using Pulumi, we'll have more Pulumi people.
In which language is generating the Pulumi code?
Python. But it can be based, like it can be JavaScript, it can be your preferred options as well. But mine is.
When you reverse.
Yeah.
And it's produced in Python.
No, it can be anything. It can be anything, but the solution is based on Python. Yeah.
So if you wanted to say run the reverse engineering, put it in YAML,
So, okay, you're asking really good questions. YAML, like that's why you need to move away from CloudFormation, right? So the main reason why I said like you may need to move away from CloudFormation is awesome. But it's like, man, like who wants to fucking write 500 lines of code when you can do it in like 50 lines, right? It's definitely good, don't get me wrong. But when it comes to like writing something which is like really developer friendly and really code friendly, I would stick to something like Python. And by the way, I was never a full-time developer. Don't think like that you need to be a full-time developer to learn Pulumi, not at all. I was never a developer, right? You just need to know cloud. If you know cloud, all these things are wrappers, right? But I have used CDK, and CDK is the next which is closer to Pulumi. But if I compare CDK and Pulumi, Pulumi basically provides you with support like Kubernetes, Cloudflare, and Dynatrace, and a lot of different things which are cloud agnostic, and you could basically, it doesn't have to be AWS specific. So yeah, that's why. So that's it. I just want to know, sorry, you had the question?
Do you have time?
Sure, bro.
Just for some curiosity.
Yeah.
Like when this tool run,
Yeah.
how, like when you design this thing, how does it grab data from the environment?
Okay, cool. So, so there's a code commit repo, which has a code, and then that code basically carefully construct that JSON file, and the way it constructs the JSON file is basically making those GET API calls to the services and gathers the required information, which will be later used for importing the resources into Pulumi stack.
So this tool, like, still out of curiosity, can that be used in other environments such as on-premise or maybe Azure?
I don't talk about Azure. I'm just kidding. No.
Just,
You can, yeah, absolutely. It's at the end of the day.
If you want to use it to extend it.
Exactly. I mean, at the end of the day, it's code, right? Like you can basically use code anyway, on premises, Azure, AWS. I mean, anything. But at this stage, I'm actually building the solution, and then God knows like where it takes me. But at the moment, it's only these services and AWS. But good point on choosing the services, and good point on like if I can basically include the other environments as well. I just need to know who were the first 3 people to ask the question. I think third one was you, and who was the second one, bro? Were you the second? Yeah. Okay, cool. I've got some good swag for you. So that's why I was like saying, please ask me a question. I've got something for you. Cool. So please meet me at the back, and I'll give you a swag. And I need to have a picture with you. Cool. Thank you so much, guys. Appreciate it.
Thank you, Dinesh. No problem. This was amazing. I have to say that I heard about Pulumi for the first time.
Awesome.
But you inspired me a lot, hopefully all of you. And I've got just few things on you. So first, before you leave,